All right. Good afternoon. We are group number 24. My name is Ryan Winterhalter, and I'm presenting alongside Jake Yocum and Thomas Rafeld. And we are presenting today our four-way traffic light intersection semester project for EECE 4038C. The presentation today will start with our abstract, and we will then move on into some introduction and background knowledge about the project. We will then move into the project objectives, talk about the technical approach for implementing the project, and then move into the budget and timeline before we conclude.
So the abstract for our project is our purpose is to eliminate any inconveniences or frustration of drivers and pedestrians waiting at a traffic intersection. Our main parts that we're going to be using is the PIC microcontroller, the LEDs, buttons, and 7-segment displays. Our microcontroller will be analyzing data from sensors to make a decision on the intersection path state. This will hopefully be balancing the safety of both pedestrians and drivers and making efficient traffic flow. We will be designing a prototype as a small scale model, but this will be scaled up or could be scaled up for a real world application. And our estimated price will be about $83.
Yeah, so for the introduction into our project is that traffic lights are critical to maintaining order during the road intersections to ensure the safety of both the drivers and the pedestrians going through those intersections. Intersections are also needed to operate during the day and the night without any human oversight or any human interaction. The incorporation of these microcontrollers and various sensors can monitor the traffic flow through this intersection. Microcontrollers will be able to determine the state of the intersection and to change the different traffic lights as needed from path 1 to path 2 based on the information it can read from the sensors. Adding additional sensors into the system will make it more complex, but adds the necessary functionalities and efficiencies to properly maintain the order of these traffic intersections.
Moving into a little bit of background information on our project, current traffic systems rely on preset, pre-programmed values rather than dynamically monitored values for determining when different traffic intersections should change state. Building traffic lights that have this dynamic allocation can help ensure smooth and optimized traffic flow, and this is becoming increasingly important as traffic patterns remain ever-changing. Readings from different sensors within these intersections can be compared using a predetermined precedence scale that can allow the intersection system to apply a state-determining algorithm. This will then allow it to decide how long each path through that intersection should be greenlit based on current traffic flows rather than predetermined values. The intersection will need to be able to balance all different types of factors, including both the presence and quantity of vehicles entering different parts of the intersection, pedestrians trying to pass through the intersection, previous greenlit path time, and more. And the sensors in this type of traffic light application can include one or any combination of radars, camera sensors, infrared motion sensors, pressure weight sensors, and more, all of which can help determine the presence and quantity of the vehicles at each entry point into the intersection.
For our project, we have 5 main objectives. Our first objective is to develop a loop system in C so that each path of our intersection is able to receive an unbiased amount of time and program the ability to set different traffic light LEDs within this. Our second objective is to use vehicle detection sensors to determine whether there are any cars and how many there are at each path in the intersection, and then relay that to the microcontroller so it can efficiently govern the intersection. Our third objective is to utilize all this data from these sensors and apply it to a path deciding algorithm, which will perform a delay and or skip in the loop to efficiently determine and set the next appropriate state. Our fourth objective will be to incorporate push buttons on each corner of the intersection to allow any pedestrians to input a delay or skip in the loop when they want to change the current state so they are able to cross the street. And our final objective will be to use 7-segment displays for displaying the remaining amount of time each pedestrian has to cross the street in the intersection before the state will change and block their ability to cross.
Yeah, so for the assumptions of this project, we said that the system will be a 4-way intersection. This intersection will be inconsistent onto which path has the more traffic, which eliminates building predetermined algorithm timers for the loop function. This project is also for intersections with only one lane, which eliminates the possibility of turn-only lanes. And then the motivation for us to build this project is that there's too many drivers and too many times that too many drivers have been frustrated sitting at red lights, and sometimes for even minutes per traffic light, while the perpendicular green lit path has no oncoming traffic. So developing a system that could better serve the community and the world to ensure people can safely and quickly get from point A to port B is an important point to us.
So for the development of this project, we will be using the PIC16F886 microcontroller and the C language in MPLab. The block diagram to the right shows how the components of this system will conceptually connect to this microcontroller. Each intersection entry point will be composed of vehicle detection sensors for monitoring the presence and quantity of vehicles entering that part of the intersection. And push buttons will also be included at each corner of the intersection for pedestrians that are attempting to cross the road. The microcontroller will act as the ultimate governing body of this system and will interpret the information from each of these sensors and will make a decision as to what state the intersection needs to be set to and when that intersection state needs to be set. We'll have 3 different LEDs representing each of the 4 different traffic lights, and we will have 7-segment displays used for conveying the remaining cross time to the pedestrians.
For our project, we will be using LEDs, 3 different colors, green, amber, and red, which will be used at each of the 4 different traffic lights. We can consolidate these and have 3 LED ports representing 2 different intersection paths, as opposite sides will always be in the same state, allowing us to use only 6 total pins for all of the LEDs. We will also be using 7-segment displays for parallel paths through the intersection, which will always have the same number, so we can have half of them read the same value while the other half are turned off. And only 7 bits will be needed to control the 7 segments, so the remaining bit on this register will be used to switch the relay, which will be able to control the other 7 segment that is on the same register. Only one 7 segment will be used to represent each of these paths. For real intersection, you would need 8 of them total, so we can simply add 3 more if this was a real world application. Vehicle detection sensor will be surveying each entry point in the intersection to determine when cars are approaching the intersection and approximately how many are waiting at each particular interpoint. When a button on the intersection corner is pressed by a pedestrian who wishes to cross the road, no matter which button is pushed, the pedestrian will wish to cross and change the flow of traffic. The system will need to take each individual button press and weigh them in comparison with the amount of cars on the road to determine which path will have precedence. And after the microcontroller determines this, it will change the LEDs and the 7-segment displays accordingly so that they all represent the desired state.
Yes. For the pin layout on our board, we plan to use port A, all 8 of the pins for the vehicle recognition sensors. For port B, we plan to use 6 pins to control the LEDs for the traffic intersection and 1 pin to read all of the pedestrian push buttons. And on port C, we plan to use the entire register to drive and select the 7-segment displays. For the code development of it, we plan to first create an unbiased loop function that will be able to output and switch between path 1 and path 2, which is creating a basic traffic light with no sensors to change the LEDs. This is what you would see at a normal intersection. Next, we plan to create some kind of bias through the LEDs to be able to change the delay in the loop. For the vehicle detection sensor, each point of entry into the intersection will be able to detect a certain amount of cars and then can branch the code into case statements depending on how many cars are into each path. The initial algorithm will be able to set up a comparison of the drivers and the pedestrians wanting to cross and then compare them based on the time from the previous path had already when it was green lit. This will be able to determine which path will then have precedence. After this, we plan to test and modify the algorithm to allow for the creation of a more efficient intersection.
Moving into the project budget, as you can see in the table on the left, we have broken it down into 6 different components that we will need: the vehicle detection sensors, the LEDs, the push buttons, the breadboard for holding all of these different components, some miniature cars for demonstrating the functionality of the system, and the 7-segment displays. And looking at the pie chart over to the right, as you can see, the vehicle detection sensors make up the vast majority of this project budget. However, this isn't a major cause for concern, as the total cost of the project is only around $83.
This is the Gantt chart that we have created for our project to follow. The vast majority of our Gantt chart time will be spent in researching, creating the project proposal, and then the design stage, which has been broken down into about 7 different tasks where we will design the LED path, then at the same time work on implementing the buttons for pedestrians and implement the 7 segments display for crosswalk countdown, as well as the vehicle detection. While we're working on all this, we will also be working on correcting and resubmitting our proposal, creating and presenting our proposal, and then our final presentation and report, with finally just testing our design and troubleshooting anything before our final demonstration at the end of November.
In conclusion, the efficient traffic flow is becoming a need with increasing populations and community development. This prototype will aim to solve many of the efficiency issues in everyday traffic lights, which will be able to reduce the driver frustrations and optimize the travel times. Our team will create a smart traffic intersection that is able to survey its surroundings and efficiently determine how to let traffic and pedestrians flow through the intersection without sacrificing the safety of those that want to pass through the intersection. Components that we will plan to use include a microcontroller, the LEDs, push buttons, a vehicle detection sensor, and 7-segmented displays to be able to determine appropriate intersection path states. Our group plans to get this finished and ready for the project demonstration by the end of November 2021.
These are our references, and thank you for watching our presentation.